Welcome to Lesson 7.2. Today we're going to talk scale factor of similar figures. Our learning objectives: being able to recognize the ratio of corresponding side lengths of similar figures as the scale factor, and being able to recognize the measures of corresponding angles being the same. Here's our introductory problem. Make sure to read through that before moving on. So similar figures are shapes that exist in proportion to each other. They have congruent angles, but their sides are different lengths. Squares, for example, are similar to each other because they always have 4 90-degree angles and 4 equal sides, even if the lengths of their sides differ. Other figures can be similar too if their angles are equal. Let's look at some pairs of similar figures. So this first one here, we know it looks similar because we've got a couple of 90-degree angles and then a 45-45. Okay, so they both have angles that match up. Same thing with this trapezoid here. We've got 55s, 125s, 55. And these last two, we call them kites. You got a 55, a 73, a 122, and a 110. So all of the angles are the same. So we can say that they do appear similar. So in this lesson, we're going to use these relationships to find the measures of unknown sides. So this method is called indirect measurement. So if you'll notice, we've got two similar rectangles here on the top. Okay, we've got one that's got side lengths of 2 and 4, and the other one that's got side lengths of 4 and 8. Now, if you remember from last time, we did corresponding sides. So this side of 2 would correspond to this side of 4. And how we get to there is we would take 2 times 2 to get 4. And that would hold true for all of the corresponding sides. So if we did this side of 4 to this side of 8, to get from 4 to 8, we would do 4 times 2 to get us 8. And that's how we use indirect measurement to find these. Same thing in the triangle here. We've got corresponding sides 2 and 6. To get from 2 to 6, we'd take 2 times 3 to get 6. And that holds true for all of the sides. So if I went from 3 to 9, I would take 3 times 3 to get 9. And finally, 3 to 9, it would be the same. 3 times 3 gets us 9. So what should happen in similar triangles is you should be able to multiply all of the sides of one triangle by the same number to get the sides of the other one, the corresponding sides. So we're going to take a step back to similar figures to understand how indirect measurement works. First, let's make sure we can recognize corresponding parts of similar figures. Similar figures have exactly the same angles. Therefore, each angle in one figure corresponds to an angle in the other. So here we've got a 50 and a 50, we've got a 100 and a 100, and a 30 and a 30. Okay, so we would say that angle C corresponds to angle R because they're the same. Angle B corresponds to angle Q because they're the same. And angle A corresponds to angle P because they're also the same. We would also use corresponding sides. So if we had the side here, BA, connecting the 100 degree and the 30 degree, it would correspond to the same side between 100 and 30 on the other one. So we would say that BA would be corresponding to QP. Same thing if we took the line between 50 and 100 in one triangle, it would be corresponding to the same line between 50 and 100 in the other. So CB and RQ would be corresponding. And same thing with the last one between 50 and 30. It would be corresponding to the side between 50 and 30 in the other triangle as well. So those ones should have a scale factor to get from one to the other. Corresponding sides also have lengths that are related even though they are not congruent. Specifically, the side lengths are proportional. In other words, take each pair of corresponding sides has the same ratio as every other pair of corresponding sides. Take a look at the rectangles below. So we've got one rectangle with sides 3 and 4. Now, if this side is 3, so is this. If this side is 4, so is that. That's how rectangles work. And we can do that with the other one as well. If this is 6, then this is going to be 6 as well. If this is 8, so is this. So what we would do is we would take the corresponding sides and make them into a ratio. So if we did 3 and 6, it doesn't matter which one we put on top as long as we start in the same shape. So if I could do 3 over 6. If I did 4 and 8, it would be 4 over 8. 3 and 6, 3 over 6. 4 and 8, 4 over 8. Now if I typed all of these in, 3 divided by 6, 4 divided by 8, 3 divided by 6, 4 divided by 8, I would get the same answer of 0.5. This would be my scale factor, 0.5, if I were going that direction. And you can see that because if you were to take one of the side lengths of 6 to get to its corresponding side of 3, I would multiply it by 0.5. And that would be the same for all of these, 0.5, 0.5, all the way around. So all of the quotients were the same, so those ratios are proportional. The side lengths are proportional and the figures are similar. We call this the scale factor. The scale factor is the ratio that determines the proportional relationship between the sides of similar figures. For the pairs of sides to be proportional to each other, they must have the same scale factor. In other words, similar figures have congruent angles and sides with the same scale factor. A scale factor of 2 means that each side of the larger figure is twice as long as the corresponding side is in the smaller figure. So our example here is what is the scale factor for the figures below. So if I look at two corresponding sides, if I take this one and this one, so I start at 5, what do I multiply 5 by to get to 15? Well, I'd multiply by 3. And I have to make sure that's true for all of them. So if I went from 2 to 6, I better make sure that 2 times 3 is 6, and it is. Same thing with to go from 7 to 21. 7 times 3 does give me 21. And for the last side, I've got 5 and 15 again. 5 times 3 would give me 15. So my scale factor here is 3. So I'm going to multiply everything by 3 to get from the smaller to the larger. What happens if we would have written the numbers the other way around? If we had put the measurements in the smaller figure on top and the larger on the bottom, we would have found the scale factor is a third. We can write them the other way too, as long as you understand how to read scale factor. This is another way of saying the scale factor is 3. When we say that the larger figure is 3 times as big as the small one, it's the same as saying that the small figure is 1/3 of the size of the larger one. So 3 and 1/3 would work the same both ways. So here we're going to look at each ratio and determine the scale factor. So to determine the scale factor, we just have to divide the top by the bottom. So for the first one, we've got 18 divided by 6 and 24 divided by 8. In both of those cases, I get 3 for an answer. Go ahead and pause the video and do these other two on your own. Make sure you get the same number and then hit play and see how you did. For the second one, for both, you should have gotten a scale factor of 2. And for the third one, for all 3 of them, you should have gotten 5 as your answer. Here we have the end of the introductory problem. Make sure to read through that before moving on. So to review, a scale factor means that all numbers have increased by the same factor. Indirect measurement is a technique that uses proportions to find a measurement when direct measurement is not possible. The scale factor is the ratio that determines the proportional relationship between the sides of similar figures. Similar figures are shapes that exist in proportion to each other. They have congruent angles, but their sides are different lengths. And similar figures have the same angle measures, but different side lengths.